Difference between IPv4 and IPv6. When discussing Internet protocols, you may have heard about IPv4 and IPv6. These two protocols are essential for how devices communicate over the Internet, but what exactly sets them apart? Let's break down their differences and why it matters. 1. What is IPv4? IPv4, that is, Internet Protocol version 4, is the fourth iteration of the Internet Protocol and has been the backbone of Internet communication since its inception. It uses a 32-bit address scheme, allowing for approximately 4.3 billion unique addresses. Example: an IPv4 address looks like this: 192.168.1.1. 2. What is IPv6? IPv6, Internet Protocol version 6, was developed to address the limitations of IPv4, specifically the shortage of available addresses due to the rapid expansion of the Internet. IPv6 uses a 128-bit address scheme, which provides a virtually unlimited number of unique IP addresses, approximately 340 undecillion. Example: an IPv6 address looks like this: 2001 0db8 8583 0000 0000 8a2e 0370 7334. 3. Key differences between IPv4 and IPv6. Address length. IPv4 uses 32-bit addresses, while IPv6 uses 128-bit addresses. Number of addresses. IPv4 can support around 4.3 billion addresses, whereas IPv6 supports an astronomical number of addresses, more than 7.9 times 10 to the 28 times the addresses of IPv4. Address format. IPv4 addresses are numeric and separated by dots, for example, 192.0.2.1, while IPv6 addresses are alphanumeric and separated by colons, for example 2001 0db8 8583 0000 0000 8a2e 0370 7334. Security. IPv6 was designed with built-in IPsec for better security, whereas IPv4 relies on external applications for encryption and authentication. Routing efficiency. IPv6 offers more efficient routing by using simplified headers and better addressing methods, improving overall network performance. Auto-configuration. IPv6 supports automatic address configuration, whereas IPv4 typically requires manual configuration or DHCP, Dynamic Host Configuration Protocol. Broadcasting. IPv4 uses broadcast to send data to all nodes, which can lead to congestion, whereas IPv6 uses multicast and anycast for more efficient data transmission. 4. Why the shift to IPv6? The main reason for the shift is the exhaustion of IPv4 addresses. With the explosion of Internet-connected devices, the pool of available IPv4 addresses has been depleted. IPv6 ensures that there are enough IP addresses to support the growing number of devices connecting to the Internet, including smartphones, IoT devices, and smart appliances. 5. Challenges with IPv6 adoption. Despite its advantages, IPv6 adoption has been slower than expected due to reason 1. Compatibility. Not all networks and devices support IPv6, leading to a need for dual-stack configurations, both IPv4 and IPv6. Reason 2. Migration costs. Upgrading infrastructure to support IPv6 can be expensive and time-consuming for organizations. Conclusion. While IPv4 and IPv6 both serve the same fundamental purpose of enabling devices to communicate over the Internet, IPv6 offers significant improvements in terms of address space, security, and performance. As the Internet continues to grow, the transition to IPv6 becomes essential to accommodate the ever-increasing number of connected devices.